Mr. Moses, good afternoon.
Yeah, Rufus, good afternoon. Happy Sunday to you.
Same to you, Aga.
You are welcome once again.
Yeah, so here again.
This is 3 minutes to 1. Yeah, we are just 2.
They will start showing up now. Everybody start popping.
Yeah, true.
By 1 o'clock now, everybody will
Yes.
start jumping.
Yeah, that's true.
But it's like we've reduced from the original number. We used to be almost 20 something before.
Yes, I also observed. I think last week we were around.
Only like 12, so.
Yes.
Or 15.
I observed that as well.
15.
15, 16. Then towards the end of towards the end of the program last week, it dropped to around 12.
Exactly. I know we're like 15. So it's not easy, Sha. It's not easy. But it's very interesting. As if I thought
Yes,
you have
yes.
learned a lot of things. You just got slicing last one.
It's interesting, really. Well done.
Thank you very much. You too.
Hello.
Good afternoon.
Yeah, good
Dr.
afternoon,
Francis.
sir.
Good afternoon, sir.
Good afternoon. How are you? Fine, thank you, sir.
Fine, thank you. How are you too?
Great. Okay.
Hello, Dr. Francis. Hello. Hello. Hello, can anybody hear me, please?
Yes, we can hear you.
Yes, we can hear
Okay.
you.
Okay. Maybe Dr. Francis isn't there yet. Thank you.
Right. All right. So are we still
Hello.
expecting anybody?
Hello, sir.
Hello. Yeah, I can hear you.
Okay, good afternoon. Please, I want to quickly pass something by you in Excel before others join, before we
Oh,
start
okay.
the SQL.
Yeah, that's fine.
Is that okay? Okay. May I proceed?
Yes, ma.
Thank you, sir. Okay, so I had this task to, okay. So it's some kind of salary rating system I had to work on this week.
Mhm.
There is the performance rating, outstanding, high, good, and all of that. There were like 5 of them. And there was the ranking system, 5, 4, 3, 2, 1. But I was able to work with that. I used data validation and all of this. I even used index matrix to create the corresponding figures and all, but later the management said they didn't want that. So the other thing they wanted was for me to gray out any rating that wasn't outstanding or high. I think I used conditional formatting for that. I used conditional formatting to gray it out. And then, then the assigning figures. They didn't want the outstanding to have a specific figure and high have a specific figure. So it was either or. I mean, it can be 2 or 1. I didn't know how to do that bit because it wasn't a fixed figure. Normally, I mean, outstanding should have, say, 2% increase and I should have 1% increase. But I didn't know how to go about that bit. So I thought of creating a column that would have a maximum of 1 or 2%, such that they could put either 1 or 2. But I had used data validation on that same column. I didn't know how to now put this second data validation row in that column, in the
The
same column.
second data validation.
Yes, in that same column. So what I did was, I don't know if it was, I created another column and used data validation, I mean, if function. I just, I can't even remember what I used there. I used if function. I just said if it is outstanding or I used if it is outstanding, it's 2%. I can't even remember what I did. But yes, I used if function at last because I couldn't put another value in the same column. I don't know if it's possible to achieve that.
So it's like you're combining 2 different lists in one data validation.
Exactly.
I've not tried, but it's, the thing with Excel, there's always a way around it, right?
Right.
So, normally if in Excel it will give you a limit. Let me see if it will work that way. I've never really tried it to try 2 lists.
Right.
Okay, no. I think what you can do. So you know the list already, right?
Yes. Outstanding. So the issue with that was the fact that both outstanding or I could take any of the should I call it variables now? Any of the values, either 1% or 2%. It wasn't fixed. So I didn't even know how to put that in formula. Say outstanding.
Okay, it wasn't fixed. It wasn't fixed, right?
Yes.
No, if it was not fixed now, so I think VLOOKUP, with VLOOKUP can work, but you will not use exact match, use approximate match.
All right. VLOOKUP, but I would have used, okay, so I'll still have to create.
You would have done it. You have just created the rough sketch, right, of what it should look like. Okay.
Okay.
Then next time, if this happens, if you have experienced something like, rather than you waiting, you can just create a rough sketch of what you want in an Excel file, then throw it to the group, then somehow work around it and find
Right.
a way to find it.
I
You get?
actually should have thought of the group because
Yeah.
it was major stress on me
Because
this
anybody
week.
that is once you're working, and that's the essence of it. We always learn from it because not every time we see different situations. So sometimes this situation will arise. So you just throw it up, just put maybe a dummy data there or dummy sample of what you want to achieve, then throw it, then put the problem there. Then let us see how we can think around it.
Okay.
Do you get?
Yeah, that's
So
what I should
just
have
in case
done.
next time, yeah.
Okay.
But try that VLOOKUP. You have that your list, so you can take any value within that particular range and you use approximate match. That's what I'm just thinking about.
But that will mean so the spreadsheet is such that we're going to share it with people, and we also didn't want them to be able to tamper with that particular sheet. So I had to lock it at some point. So I just wanted it to generate.
But you know, in Excel you can also hide sheets, right?
Yes.
So if
So
you
when I
lock
hide
it,
it, they can't see it. They can't see whatever. I mean, they can't open it on their end. They can't do
yes,
the unhide on their end.
yes, especially if it's locked, yes.
Lock. Okay.
Yes,
Okay,
if
I'll
it's
try
locked,
those out.
then you can hide it, yes. But if you just do a sample, you can try it on the video, look at it.
I think I'll still go that route. I'll create a sample and share.
Yeah, create that sample and share.
Okay.
Because
Thank
if we
you.
stay in Excel, we can stay Excel throughout this whole year, we'll still not finish it. You get? So
Right.
maybe all we'll just do, let's just start something else. Then maybe before the end of it, we can do another batch of Excel again before we transition to something else.
Okay. Okay. Thank you very much, sir.
All right. That's fine. All right. I hope we have tried to install MySQL now. Yes, Wale, he said your own system will not allow you. There are also some other online platforms, but I don't know how well it will work. Sometimes it works, sometimes it doesn't work with all the syntax. So I don't know. So I don't know, maybe try this one if this one will work, but I don't know. Then there's another one again.
Okay, I'll try.
W3 School. But that one is while you are learning, they will allow you to type them online. So learn to code SQL. Let me see. Okay, also try this W3 School, but this one you have to go step by step, but they will allow you to but it will allow you to run some, or maybe not all. Let me see. But this one is just like you just follow their step by step, and it will allow you to run it online. Yeah, admin. Okay. All right. So let me look for my slides. But apart from Moses, who again? Wale, do you all have our MySQL installed now?
Doctor, good afternoon.
Yeah, good afternoon.
I couldn't install.
I followed that video you sent. I've downloaded it. Even though I don't know what I'm doing yet.
Wait, the important thing, at least you know how to install now.
I've been battling.
To install.
Yes, it's like I don't know whether there's protection on my computer. So, but
okay, maybe that is from your computer. Then, but normally, sure, everything just next. All right. Yeah. Error? Or someone saying something just now.
Yeah, you gave us 2 links. There's one for community download, SQL, MySQL, and the other one, the last one. I tried the last one, and is the one that I have. So I went back to do the MySQL community download. So I don't.
Okay.
Yes.
All right.
Good afternoon, doctor.
Yeah, good afternoon, Prof.
So I'm on the second one. I'm installing the product. So I'm on my SQL shell.
Okay.
That's fine.
You're using my SQL workbench.
I'm just following that YouTube video you
Okay,
sent.
okay,
So
okay.
mine is following that process.
So you have downloaded the workbench.
Yes, I have. And
Yeah,
the
that's
server.
good. Then please make sure any password you put there, write it down somewhere. I know you forget it later. Write it down somewhere.
Okay, sir.
Okay, so let's start. So we have been working with Excel since, right? So
Good afternoon, Dr. Francis.
afternoon, Prof.
Okay, sir. Me, I'm having issues with installation because when I started off, I did the basic, right? So that's what you're supposed to do. I did the basic and it just popped up an exclamation that unable to install. And the message is that I should exit. A previous installation required the reboot of the machine for changes to take effect. To proceed, restart your computer and then run setup again. So
Let me, you know what? Okay, let's.
Sorry, Francis.
Yeah, I'm
That was
just
the
trying.
error.
Yeah, I'm just thinking because if I start to sort everybody's installation, we may not do anything today.
No, but I got that same error.
You got the same error.
Yes, that's when I reached out to you. So if you actually do restart your system and do the setup again, it would install. So that's
Yeah.
what.
okay.
Then for some people, you need to install some other dependencies. Like you ask you for Visual Studio, C++. You need to go and install those ones first before it will work. Yes. But please, any other person who has already done Zoom, please, anybody that is having challenge, please reach out to the other people, okay? So that they can assist you. Yes, it's not supposed to be straightforward, but some systems may not be that straightforward. Okay, yours did not ask for password. Are you sure you got to the right place? Up to, did you ask you for root password?
I just got there now. The root password.
Okay. Please remember this password though. All right, so okay, that's if he didn't ask you, then that's fine. If he didn't ask you, then that's fine. Then you're lucky then. Okay, so far we have been looking at Excel. Okay, we have been looking at Excel. So almost everything we are going to be doing as analysts, right? You can actually use Excel to do it. Okay. So from extraction of data, cleaning data, analyze data, and do your reports. Okay. You can use Excel to actually do everything. But the challenge with Excel is that as the organization keeps growing, transaction keeps growing, it will get to a point that you outgrow Excel. Okay. How many columns, rows do you have in Excel? How many rows do you have in Excel?
104856.
So imagine your transaction gets to 2 million. What will happen? You now have to open another Excel sheet now, isn't it? So if it gets to 3 million, you go to the next Excel sheet. 5 million, you start opening different Excel sheets. But you see, there will be no way to allow the data to flow. That means your analysis will break. You'll do one sheet, keep it somewhere. Do another sheet, keep it somewhere. Do another sheet, keep it somewhere. Then now consolidate everything and now add up everything. Now imagine now you want to now do a refresh or something on that kind of report. You see, it now becomes very slow. And when the Excel file becomes large, maybe imagine your file gets maybe to 200 or 300 megabyte Excel file. Try and open it. Okay. I think I have one Excel file, maybe up to 400 or 500. The system struggles to open it. Struggles to open it. Okay. So with that situation, you see that Excel, yes, you can use Excel as a database, but it gets to a point that Excel becomes overwhelmed, especially data that is growing every day. You get to a point that Excel becomes overwhelmed. Okay, and that's where you understand that even the way you do your formulas matter. Okay, because there are some formulas that are more efficient than the others. It is when you have a very large data set that you know that the way you write your formulas also matter. So you have to look for the most efficient way of writing it. Okay. So when it comes to limitation in terms of the size of the Excel file, in terms of how you relate with the data from different Excel sheets, okay, in terms of the speeds. So you see that Excel has what limitation. So you now have to move towards a proper database. Okay, so rather than you using your Excel as a database, so it's better you use a proper what database. Then you also notice that even when you want to, and that challenge again, sometimes security, okay, that even when you try to say, oh, I lock a particular sheet or not, that somebody should not access it. And somehow, as long as you can have access to that Excel file, you can still unlock it. You can still have a way of unlocking it. It will be easier to unlock it in Excel than in a proper database. Not that you cannot unlock in a database, but it will take you some time. At least you sweat a lot. But for Excel, you won't sweat so much. Okay? So there are ways of doing that. So in terms of security, even when you open the files, you can just see the whole data at once. Okay? So in terms of security, privacy, Excel is still limited as a database. Okay? So that's why you see gradually you need to, all as a data analyst, you also need to get a proper database. And also understand that when we are learning SQL as data analysts, we are not learning SQL as database administrators. They are two different things. Okay? Because in most organizations, they already have their infrastructure already that they already have in place. You are not the one building anything. Unless it's your own private business that you can now build your own database. Or it's a small business that you can build your own database for them. Okay? But in most organizations, you will notice that they already have their own database. Okay? So that's why we are going to be looking at understanding SQL from a data analyst point, and in the assumption that most of us are non-programmers. Okay? So basically, we have already understood what data analytics is about. Okay, we are going to understand what a database is, reason for database, why SQL, classification of SQL, then guide to interacting with the database. Okay, so as we already know that when we talk about data analytics, right, it's about understanding what the data to derive what insights that drive business work decisions. Okay. And we must understand that this, whether it's data science you call it or data analytics you are calling it, all the tools we are learning, they are just tools. It's a means to an end, not the end in itself. That you have learned SQL, you have learned Python, it's not the end in itself. It's just a tool. Okay? It's just a tool. And if we remember the framework, first, the most important thing is understanding the business problem, okay? Once you understand that, the next thing is understanding the question that you need to answer. To answer those questions, you need data, okay? And your domain will enable you to interpret the data and understand the data better. And we have also seen that almost 80 or 90% of the time, the data is never clean. So you spend most time cleaning, preparing the data before you talk about analyzing and modeling the data. Then the next thing, you must validate whether the report is giving is answering those questions you asked. Then last thing is to do a presentation or visualization. Okay. So our focus most time is on extraction, analysis, and visualization. Okay. So what we have been doing in Excel is on the analysis part and maybe visualization part. Okay. But it is assumed that the data has already been given to you. Okay, it's already given to you. So what we are going to be learning now is that most times you don't need to tell IT, give me data. Just tell IT, I need the access now. So you just access the database and query the data yourself. So at this point, what we are going to be learning is how to extract the data. So whether you are doing extraction, analysis, or visualization, we have tools that we use. Okay, so for extraction of data, we use what? SQL. Okay, for analysis of data, you can use your Excel, you can use Python, you can use R. For visualization, you can use your Excel, you can use your Power BI, you can use your tablet. Okay, or other tools. Okay, so that's why we have different analytic tools and they have their own specific purpose. Okay, so that's why sometimes we learn almost everything. Okay, so when we talk about a database now, just understand a database. For example, if I tell you to write your date of birth, write your date of birth. Some people within a second they can write it now, isn't it? They can write their date of birth. But where is that date of birth? Where is it stored? Where is the date of birth? Where is it stored? Where is the date of birth? Where is this, your date of birth? Where is it stored?
In our mind.
In your mind, is it not?
Stored in our memory.
In your memory, your brain, is it not? Your brain is also a database. And that's the largest database you can imagine. Okay. So whenever I talk about a database is anything, any container that can store something. But here we are talking about data, right? So any container that can be used to store what? Data. And if you remember, data, they are the raw word facts. Raw word facts. It can be raw values, raw figures. Okay. So a database is simply what? A collection of data that's organized in such a way that you can easily what? Access it, that is retrieve it, manage the data, and easily what? Update the data. Okay, but just understand when you hear a database, if you check your phone book, you go to your contacts, that's a database. Or you open your, so some people can have it on phone, some people still have book where they write names, number, or they made sales, they write it in book. This person bought today, they write date, write what he bought, write the quantity. It's still a database. Okay. But we must look at it two ways. You have a manual database and a computer database. Okay. For the purpose here, we are talking about a computer database. Okay. And I've already tried to explain why you see that people are now moving from proper Excel to what a proper what database. Because imagine you have a situation where you have so many spreadsheets all over, so many spreadsheets. So you now need to sit down to start consolidating all the spreadsheets. And when all the spreadsheets are not uniform, you see, it takes you longer time to try and what? Consolidate all together. Okay. And again, whenever you are working with an Excel file, that Excel file with one big sheet, they call it a flat file. is called a flat file. Okay, and you also notice that so many columns there are redundant. Means you cannot you can't even use them for anything. Some you can use for analysis, some you don't use them for any analysis. Okay, so you have a lot of redundant columns there. And the more columns you have in your table, the larger the file. Okay. Then sometimes before with the traditional Excel, you have to be sending files back and forth. Okay. But now with the way you can now share Excel online now, different people can work on Excel at the same time. But traditionally before, you only have to be exchanging emails. Okay. But over time, that has changed with Excel. Okay. Then again, in terms of the security parts, the Excel's security is also very limited, very limited, very limited. Okay, so that's why database now comes to take over all this one. You should take care of most of these issues. Okay, so yes, a database is just any container where you store what data. Okay, so anywhere you store what data. So most time that way when we get to database objects, we'll now see that when we talk about a database is not just a table, it's more than a table. So in Excel, what we are used to is a table. What we are used to in Excel is a table. So that way we can say that a table, let's say a table is a database, but not all table. A table is a database, but not all databases are tables. That's it. No, a database is a table, right? But not all tables are database. Let me not say something to confuse us. But what we are just saying here that a table is part of a database. So a database is more than just a table. Okay. But you see, that table is stored somewhere. It's stored somewhere, it's stored in a software. So that software where you store those tables is called database management system. So anytime you hear DBMS, they are talking about the software that you use the word creating and managing that database. Okay. So whenever you hear what DBMS are you using? So they are talking about the type of database software. So you can talk about Oracle. You can talk about Microsoft SQL Server. You can talk about MySQL. This MySQL is the free version of Oracle. This MySQL is the open source. This Oracle, when you hear Oracle 12G, Oracle 13G, or 12C, these are the enterprise versions, but this is the open source version. So MySQL is also Oracle. Okay. Then you have Microsoft SQL Server, you have SQLite, you have PostgreSQL. So you have quite a number of them. Okay. You have quite a number of them. Okay. So it is that DBMS that used to store your data base. Okay. So when you talk about this, when you hear DBMS is what the software. It's just like you have Excel. Excel, you are using to store the data there. Okay. So that's the same way you have Oracle like Excel that is helping you to store your database. Are we clear with this concept?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
That's fine. So whenever you hear DBMS, they're talking about the software. Or when they say what flavor, they are still talking about the type you are talking about. So most time we talk about the flat file. So just that your Excel file is a flat file. So you can just have one file and you have all the columns there. Sometimes when that file becomes so large and you want to look for something or do corrections, you see, you have to go and look for everywhere that is located and you start correcting. But sometimes it's not efficient. It's not efficient. Okay. And we see it especially when we have large Excel files. You see how difficult it is to manipulate it. Okay. So with a flat file, sometimes it may be difficult to have different users working at the same time. Okay. Then you see again, as your data is growing, it will get to a point that it will stop. So once you get to 1,048,000, then your data stops there, except you go and open another sheet again, and that discontinues every flow. So imagine I want to sum up. It means I have to sum up one sheet, sum up second sheet, sum up third sheet. Then now add the sum of first sheet, second sheet, and third sheet to now get the total. So imagine I want to get for different regions. Let's say I will look at sheet 1, sheet 3, sheet 4, sheet 5 to get one particular. So sometimes it can break down. Okay. So working with large data sets in Excel has this limitation. And I mentioned there are a lot of redundant columns that you may not need. Okay. But it is cheaper to work in Excel. Okay, because almost every organization have Excel. Okay, so it's cheaper to work with than to go and build a proper database for the organization. Okay, sometimes costly to subscribe for it. Okay, then in terms of, so for example, with the Excel, you don't need an IT department, okay, to handle that. You see, because of security issues, right? So you now need somebody to be in charge of what your database, that you can allow you to have access, revoke your access, grant you access, and what have you. Okay, give you whatever data that you need. So you need somebody there to manage. But for your normal Excel file, you don't need somebody to be there. If you are admin, you can just put password there and restrict them from that. Okay, to some extent you can, but you don't necessarily need a core personnel to be dedicated to that Excel file. No. But for your database, yes, you will need somebody there. Okay. Another thing again you will notice is that your database can be applied everywhere, in every field. You can apply it. Every field you can apply it. In every field you can apply it. Okay, in every field you can apply it. Okay, whether it's in the banks, in airlines, universities, telco, finance, sales, manufacturing, accounting, HR, you can apply it in almost every field. Okay, especially now that everything is data driven. So as you are working, you are thinking about how do I measure this and keep it and start generating my database. Because this data you keep today will be analyzed sometime in the future. So you must start storing the data in a way that it can scale in the future. Okay, so that's why most times you see them use a database. So why MySQL? So we have seen that we have a lot, right? We have a lot of DBMS, okay? But first of all, why I usually prefer starting with MySQL is that it is open source. That means it's free. Secondly, I think it's one of the easiest to learn. Okay, it's one of the easiest to learn. Okay, and it can work with almost any platform. That's why you see when they are teaching web development, right? They are teaching how to build web. You will notice that sometimes even the data you enter in the front end, you say enter username and password before you have access. That username and password is going to check against something at the back end. You see, that back end, there's a database there. So when you enter name, you have a registration form, enter name, enter this, enter all the information, enter. It's going to the back end. That your user interface is the front end. Okay, but where that data is stored at the back end, okay, that is your database. So sometimes with MySQL, it's easy to connect with it. That's why you see most people use MySQL again. Okay, so very easy to work with. Okay, and yes, that's basically it. Okay, so some other things we are going to also see. Some other concepts we are going to see. Though this is the boring part. This is the boring part of it, because if I don't go through this, if we go straight into the coding, we go straight into the MySQL. Sometimes you may not understand why you are doing it. Okay, you are just, I want a situation where you are not learning the code in itself, but understand why you are doing it. Okay, Because sometimes you may not be the one you have to do it. You may work with a team that you have somebody that is database administrator or data engineer, but you must understand what they are doing. Okay, you must understand what they are doing. Okay, so for your Excel file, right, we talk about a flat file. Isn't it one big file that contains everything? So that's a flat file. So if you remember that superstore data, you remember the superstore data?
Yes,
Yes,
sir.
sir.
So that superstore, just imagine that superstore data. That is just one file, isn't it? That is just one file. So that is a flat, that is an example of a flat file.
Sorry, Dr. Francis, which one is superstore data? I don't know that data.
The one you could use to do your dashboard now.
For the dashboard,
The marketing data.
the marketing data.
Some use marketing data,
okay.
some use the one we have been using in Excel now to do pivot table, convert to table. Because that data set is a classic data set that can be used for almost everything you are learning in data science. So just imagine that big table. Even you just think of one big table. Okay. But you see, if I want to do any correction, I have to go and look for the columns where it applies or select the entire sheet, right? Then find and replace. But what if I'm finding and replacing, but I'm not replacing everything? So it means I have to go column by column to start checking. So imagine I have 10,000 columns there. Okay. So the way you have to do it, you have to now be more to stress you. It's not that you cannot do it, but you take more stress to do any kind of update or correction you want to do on that kind of file. Okay. But with a database, so rather than having one big table, what do? You now break them into smaller tables. You now break them into smaller tables. They now have a way of connecting the two tables together. So just imagine one table will be a database, and that table is a database, but there will be something to connect these two tables together. Then we refer to it as a relational database. It now be called a relational database. Did we get that? So rather than having one big table, you rather have smaller tables, but have a way of linking those tables together. So we now call that relational database. The same thing here. You can have a full table here. You can have a full table here, but you have different aspects. That this one's only students, this one has only class ID, but they can come together to now form one table, because there are some students that are taking certain class. So where the particular student is taking this particular class, then they will now match. So that's why you have this one here, this one here. So rather than me having one big table, I will have two small tables. Okay, where they match together, then I will now have a full table like this. So rather than me having one big Excel file that I will call a flat file, it's better to have smaller tables. Then we'll now find a way of linking them together. So that's what we refer to as a relational database. Are you clear with the concept of relational database?
Yes, Dr. Francis.
All right, relational. But although we'll still see it again, this is another one again. Okay, a relational database. Okay. If you remember again, when we were talking about in the Excel, when we're working with the Excel sheets, there are certain rules we mentioned. What are those rules that we mentioned in Excel?
No blank rows. It must have a header.
Yes.
No merging of cell.
No merging of cells. Yes.
Nothing
should be written around the table.
Good.
No empty spaces.
Unique ID for each record.
Yes, it must have unique. So you see, those principles are part of a database. Because every table must have a unique identifier, something to uniquely identify it. Okay, it is that unique identification that I can now easily link them. So this is now the relationship we are talking about. So we can have what they call a one-to-many relationship. We can have what they call a many-to-many relationship. We can have what they call a one-to-one relationship. Okay, so at the end of the day, what you are trying to build is what they call a data model. Have you heard of data modeling? Have you heard of data modeling?
No, sir.
No.
Okay.
Yes.
Now, especially when you are working with Power BI, when we get to Power BI, when you are dragging and dropping to be getting your visuals, it's getting your visual because the tables are related. So that's why you must specify how is this table related to this table. So that's why I'm not going to have two huge tables. I can have two smaller tables, but they can easily work link with every other table I have there. Okay. So what you are building is what they call a data model. But for a data model to work, it must work on a relational database. Okay, it must work on a relational database. Can you see that this is student table, this is enrollment table, this is a class table? Let's say these are different databases, but somehow they are related. Are you seeing that they are related? Student IT is also related to enrollment. Can you see that? Class ID is also related to this table. But is student table related to classes table? Is this student table, is it related with this class table?
No.
No.
Yeah?
No.
No.
Why?
It's related indirectly, not directly.
It's related what?
Exactly.
Indirectly. Exactly. It's related what? Indirectly.
Indirectly.
Exactly. And that is exactly what we call a relationship. It has a relationship, but not direct. It can be indirect. So that means I can get the student, maybe the student's class name from student ID. Not because I can link them directly, but I can link it directly from here. So that means if I know who this guy is, then I can trace who this guy is from here. And this guy will automatically link to this guy. So you see, when I have smaller tables, it means if I want to do a correction, imagine if it was an Excel file. So this is sheet 1, sheet 2, sheet 3. If it was an Excel file, I want to correct this person's name. You know what I will do? I'll come to sheet 1, correct the person's name. Come to sheet 2, correct the person's name. Come to sheet 3, correct the person's name. Imagine now I corrected the person's name here. I forgot to correct it on sheet 2 and sheet 3. Can you see? But with a database, I don't need to bother myself. I only correct it here once, that's all. And every other thing will be corrected. Because I don't even need to do any other correction. It's only in this table, that's all. And it will link to every other table. So with database, it makes working with data very easy and efficient. Okay, makes working with data very easy and efficient. All right. I will still come back to this, but let me just explain certain things. So all these that we are calling tables, we can also call them database. Yeah. So I said a table is part of a database, but a database is more than a table. Okay. So just think about it. Yes, a table is a database. So anytime I'm talking about a database, just think about it in form of a table. But later we'll see that a database is more than just a table. Okay, so one of the concepts here we see is a table, and that one we are familiar with that, especially in Excel. Okay, because when we talk about tables here, and remember that thing again, when we talk about data, we can look at it in two parts. We can look at what they call big data. You know, when we talk about big data is talking about structured and unstructured. So when we talk about structured data, think about Excel, it's structured data. Then we also have what they call unstructured data. So it's data that is the database that does not have tables, normal tables like columns and rows. That is now what unstructured data. It has a database to also store that kind of data. Okay. So here we are dealing with what is structured data. That's why you hear the name structured query language, SQL. Structured. So what we are dealing here with is structured. Okay, so think about what a table, and we know that a table is made up of what? Rows and what? Columns. Is that not true? Your table is made up of what? Rows
Yes, sir.
and what?
Rows and
Columns.
columns.
But in database terminology, you don't call it rows, you don't call it columns. What do we call it? For your columns, you call it what?
Record.
No, you call it fields.
Field, rather, sir.
You call it field or what? Attributes. It's called field or what? Attributes. That is why, if those of you who are familiar with Power BI, when you do any transformation, it will turn that field into attributes. You call it attributes. So that's what you are seeing there. So a column is either called what? A field or what? Attribute. Sometimes you use them interchangeably. Okay. In Excel, we call them normal table. In a database, we call them what? Fields or attributes. Okay. So this is what? A field. A field. So when you hear field name, what are they talking about? When you hear field name, what are they talking about?
Column name.
Column name, exactly.
Column.
Talking about column name. Okay. Now for your row, what do they call rows?
Record.
Rows are called what?
Record.
Records. They are called what? Records. Okay. They are called what? Records. They are called what? Records. Okay. They are called records. And every record, must contain what? Unique what? Values. You must have something that is what? Unique. Okay. Yes. That is why you do not merge. Do not merge. Okay. Because Excel is so flexible, it allows you to merge. Okay. But when you are following the database principle, every record must be unique. There must be something to uniquely identify that record. Okay. So that is why to uniquely identify that record, you have what they call keys. You have what they call what? Keys. Okay. And most time your keys can either be called the primary key. You have what they call the primary key and what? The foreign key. A primary key and a foreign word key. Okay. So, but I'm not going into the details. So if you look at this, so imagine this is the student table or the student database. This is the course database or course tables. Okay. Now, what uniquely identifies a student? What uniquely identifies a student?
The student ID.
The student ID. So student ID in this case becomes what? Student ID becomes what?
Primary key.
It's called a primary key.
Oh, okay.
Primary key.
It's called what? A primary what? Yes,
Key.
generally all of them are called fields, right? Each column are called fields. But that particular field that makes this table different from any other table is known as what? A primary what? Key. Are you clear with that? This is cost
Yes,
table.
sir.
This is cost table, right? What is the unique identifier in the cost table? What uniquely
Course
identifies
ID.
course ID, isn't it? Do you see that you also have course ID on your student table?
Yes.
So course ID was a primary key here now, isn't it? Course ID was a primary key in a course table, is it not?
Yes, sir.
Yes. So a primary key that is found in another table is now called what? A foreign key. It's called what?
A foreign key.
Foreign key.
Foreign key. Now, because this table has course ID, this table also have course ID. Do they have a relationship? Do they have a
Yes,
relationship?
there's a relationship.
Yes,
Yes.
sir.
So this is what they call relational word database. Think about it this way. So there's something about this database. There's something about this database. There's something that's connecting them together. So they are what? Related. So that's what they call what? Relational word database. Is this clear?
Relational what, doctor?
Database, relational database.
Okay.
Relational or database. So even if your Excel keeps a database, but it's not a relational database, even if you use your Excel as a database, it's not relational database. Because you are just working with different sheets. Okay, it's not necessarily what relational what database. Okay, so you must have something that unique. So that is why anytime you are creating a table, always ask yourself, what uniquely identifies this table in such a way that it cannot be what duplicated or it cannot be ambiguous. If you think about it, let's say, for example, if I have a product, right? If I have product, so I have product ID, I have product name, I have category, I have subcategory. So what would be the unique identifier for a product table?
Product ID.
Product what?
Product ID.
Product ID. Now, do you know that sometimes you may have different products under the same category? Isn't it? They may be under the same category. And because they're under the same category, they are expected to have, are they expected to have the same product ID?
No.
Not really.
Not really. Isn't it? Not really. Because that product category can have other different what categories that should have what their own names and linked to their own ID. But you see situations where they use only the product ID to link it with what the product was category. But that product category have other different what products inside it. So in that case, you now have to be careful whether that product ID uniquely identifies that table. So that's why you can have more than one table or more than one field or more than one column that we can use as what? A primary what key. If we have more than one column that can be used as the primary key, then we call that, I think they call it candidate key. They call it candidate key. You know, in politics, these are our candidates. So it's called a candidate key. Candidate key, which means any of them can be a primary key because each of them uniquely identifies it. But when you have that, you have to combine two different columns to now become unique primary key. So it is called what? A composite key. It's called what? Composite key. I don't know, do we get this concept?
One is not clear. Composite.
Composites, when you combine two different columns.
Yes, to now make it primary, to now make it what? Unique. It's called a composite.
Okay.
Do you understand? For example, in a particular class, right? In a particular class, normally, if you look at the whole database, you see that no two persons have the same name. No two persons have the same name. Then in that case, first name can be a primary key. Now, is it not? Last name can be a primary key. Is that not true?
Yes.
So if I can use first name as primary key or last name as primary because no two persons have the same thing, then this is what they call what? A candidate what? Key. It can be any of them. Do you see that?
Yeah.
But in a situation where we have two people having the same first name, but they all have different last name, then I can combine first name and last name to now become what?
Okay, composite key.
Which now makes it what? I don't know, did you understand that now?
Yes, I do.
All right. So that's why whenever you're having a database, there must be something always uniquely identifying your table. Okay? So that's how you must always think about it. What is uniquely identifying? And that thing you must always think about. How can I link this table with this table? Sometimes they may not have any relationship, but you can create something that what links both of them together. Okay, so that's why when we talk about relational, we must always think about how is this table relating with this table. Even if it's not relating directly, can it be related with another table? If the answer is yes, then I will take whatever can relate to this table, put it one side. Whatever relates to this table, take one side. Whatever relates to the other table, take one side. So I will now have a new one. So this one will link with this will link with this. Then they can now have that indirect relationship. So that's why when we are building the database, we must always think about how are they related. The good news is that you are working as data analyst, not that database administrator. So that will be the job of a database administrator. And most organizations already have it established. Your own job is just to collect the data and think about how to link them and do your analysis. Okay? And how you should also think about it in form of your, your pivot tables, right? You know the pivot tables. You know how you drag and drop.
Yes.
You know how you drag one column, you drag one column you drag one on the row side, you drag another one to the values, and you're getting your analysis. Because there's a relationship there. So that relationship was found in one big table. So imagine they are in different databases. So I will pick one from one database, put on the row side, pick another one from another database, put on the value side. Then I will now get out my pivot table. That's exactly what you are trying to do. But only in this case, you are not using mouse to drag and drop. They are now writing code to do that. That's just the difference. Okay. So what you are trying to establish with the kind of analysis you are doing, think about it in terms of your pivot tables you're doing in Excel. That's exactly what you are trying to do in your SQL. Now I say data analytics using SQL. So the same thing you are doing with your pivot table, that's exactly the same thing you want to try and do here. But the only difference now is that you are not using mouse to drag and drop. You are not writing code to do that. Can I make progress?
Yes, sir.
Are we clear with this concept now? Primary key, foreign key, relationship, composite key, candidate key. Do you understand that?
Yes, sir.
Yes, sir.
Yes?
Yes, sir.
All right, then that's fine. All right, that's fine. Good. So it's as a result of understanding how this relationship works. Then you now talk about what? Your star schema. How many of us have worked with Power BI here? How many of us have worked with Power BI? Nobody?
I have, Doctor.
You have, okay, good. So that's your Power BI. When you are dragging and dropping, you see when you go to data model, you see something like this.
Yeah, to connect two tables.
To connect exactly those different tables together.
Yes.
It is on the basis that you have a good understanding of what the database is and how they are linked. How it's linked works with what? Which relationship is this? What kind of relationship is this?
Relational.
It works with that relational database. Okay. But in terms of the relation, we now have different types of relationship. So technically, that relationship, we call it what? Cardinality. That relationship, the technical name is called cardinality. Have you heard of cardinality? So when you hear one to many relationship, many to one relationship, one to one relationship, many to many, I'm sure you have heard of this one. So when we talk about the relationship, what kind of relationships do we have? Relationship. It should have what? Which relationship is ideal?
One to one.
One to many.
One to many.
No.
And then maybe many to one.
Yes, either of this one. Either one to many or many to one. This one is a normal table. What you have in your normal table. Let me go back to this other table. Okay, maybe I'll use another table to show it. Can you see this one? Just imagine this one is in one table. This is another table. They are not bringing them together. And they can match themselves together now. So that's a one-to-one. So whatever I'm seeing here is exactly what I'm seeing on that table. Whatever I'm seeing here is what I'm seeing in the other table. So I can bring them together. So that's a one-to-one. So that one is straightforward. What we want to see is what? A one-to-many relationship. What's your Power BI? Imagine your pivot table. You know what your pivot table? So imagine you have different departments. You have different departments. Maybe you have 5 departments in the organization. But that 5 departments, you can have 10,000 employees. That your 10,000 employees, you know, can only be found in how many departments? Can be found in how many departments?
One.
One department at a time.
Yes, one department at a time, is it not? But you only have 5 unique departments. So that is why when you use pivot table and you drag department to the row, what will happen? It will only show you your 5 departments.
Yes.
Isn't it?
Yes, yes.
Then when you now take employee to values, it will now do a count. Maybe accounting department 20, sales department 1,000, marketing department 500. Then you now have your what table that way, isn't it? So what are you doing there? You are doing what? A one-to-many relationship. Did you get that?
So please, could you say that again?
Can you imagine your pivot tables, the way you analyze using pivot tables?
Yes.
So go back to think about that, your pivot table. Imagine when you take category on that superstore data. How many categories did we have? How many categories did we have?
We had about 5 or so.
No, we had just 3 now. I think it was
3.
I think it was 3 now. What were they? We have office. Was it office?
Office supplies.
Office supplies, technology, and one other one. Okay, we had just 3, isn't it? So you see that 3 is unique. That means that's the one. But the sales you have made, you had up to 10,000 transactions, isn't it?
Yes,
we
sir.
had about what 10,000 word transactions. So that is the
Transactions.
one. This is the one. This is the word many. Okay. So when we drag, so for example, imagine this is category. This is what category, and this is your sales. So when we drag it now on a pivot table, what do we have? We have category here. Now, is it not? We have category here. We have category 1, category 2, category 3. Then we can have here, let's say 100. We can have here 200. We can have here 300. Then at the end, this is what you now go and visualize. Is that not what you do? This is what you visualize. Now imagine that this transaction was up to 4 million. Can you have up to 4 million transactions next year?
No.
Can you have up to 4 million transactions next year?
No.
No.
So that is why if your transaction is less than 1 million, please remain with Excel. But the moment your transaction is going 2 million, 3 million, 4 million, 10 million, Excel cannot handle that. So that is why you now move towards a proper what database. So that very big table, we will now break it into what smaller tables. That process of breaking into smaller tables is called what? Data normalization. It's called what? Data what? Normalization. You see, what I'm showing you, I'm teaching you based on how you do it as data analyst, what you do. For database administrator, they don't think like this. Okay, they are not thinking of the analysis part. What are they thinking about? How do I what? Collect the data, create it to make sure that it's efficient, have it linked together. That's all. Your own role as analysis, how do I connect to that database?
pull the data and what? Do my report. Can you see the difference? So now that database administrator, his role gradually has started evolving, because sometimes the database is not stored in one place, because you need to go and get the data from different sources. So you now have to pull the data from these different sources and take it to one database. They now call that a data warehouse. So that person now, they call that person a data engineer. I'm sure you have heard of a data engineer. Have you heard of data engineer?
Yes, sir. I heard it from you.
From you,
Yeah,
sir.
so a
From
data
you.
engineer is more like it's a modern version of a database administrator. But his own job is to ensure that he pulls all the data from the different sources and push it to a database. So that database, you can sometimes also call it a data warehouse. But remember, you are pulling from different world sources. A typical database administrator will just take maybe from one file, just go and populate and create the database for you, just in one place. But the data engineer is getting data from different sources, cleaning, transforming the data, and pushing it. Okay, so that is why his role is also what evolving.
Yeah, thank you, doctor, for this actually, because it's I never knew maybe people that do that, are called data engineer. It is that because it's that sector we have for our Power BI. The system, that means the accounting softwares, we cannot direct access to it. So the access. So we have the data warehouse, and we have two different systems, one for billing, one for accounting. So information at that point is consolidated at the data warehouse. And that is our IT team. So our Power BI is connected to our data warehouse.
So that data warehouse, exactly.
So it just came in from a time, like it's updated every 6 hours.
6 hours. And most time that your database, sometimes it cannot be live. It may be T-1, maybe -1 hour, -6 hours. For security reasons.
Yeah, it is not, yeah. That is 6 hours.
Yours is 6 hours. Good.
Yeah.
Some people's own is 24 hours. Some can be 24 hours.
Come here, come here.
Yes, we are here.
Come here, Joe.
We are here. Oh. All right, thanks for clarifying that. So if anybody also has any example that they can give in the organization, you can also share so that we can also clarify. Because sometimes these concepts, they may look, I can't differentiate who is data, because that I told you from the beginning, forget about who is a data scientist, who is a data analyst, who is a data engineer, who is a machine learning engineer. Yeah. As you keep understanding the tools, you start understanding your role is a little bit different and specific. Okay, some are not more specialized. You can see that you can call the person a data analyst, but he's doing the data engineer's work. He's doing the data visualization specialist work. He's doing the machine learning engineer's work, but they call him a data analyst. But in more structured or more larger organizations, each role is you are now specific. You now have specific tasks you are doing. The person doing data, he does not even do any cleaning. His own job is just only do data visualization. There are some people on their own is just to what? Pull the data from the different sources, pull it and push it to you. That one is data engineer. You have the data scientist there, that one that will now build the models, build a prediction model, push it there for you. Then you have somebody who wants to now deploy it. You now take that model, now build it in form of a software or a website. Then they call that one a machine learning engineer. Okay, but one person can actually do almost everything. So that way here a data scientist basically can do almost everything. So his skill set is much more broader than a data analyst. A data analyst, you just stop somewhere, you have learned Excel, you have learned your SQL, you have learned your Power BI, you are okay. You are okay. Then a bit of Python. Okay, then you call that a data analyst. But when you now start building models, pulling from different sources, cleaning, transforming, deploying, and all, then if you go through the whole pipeline, then they call you what? A data scientist. Now I've told you that the role is also changing. You now have who they call analytics engineer. So the same way we have been hearing, they are making noise about data scientists. In the next 2-3 years, you start hearing analytics engineer. We are looking to fill the role of an analytic engineer. So it keeps evolving. So that's why I say don't bother about the different terms, their different rules. Just understand that as you understand each of the tools, you understand, okay, this is what this tool is specialized in doing. Then based on that, you know if this is my own field or not, whether this is what you want to do or not. Okay. But for data analysts, most time, one of the requirements is to understand what SQL. Because most of the transactions, Excel cannot handle them. It cannot handle them because they are so large. Okay. So you must now think about how do I now break that big table into what? Smaller bits. So that process is known as what? Data normalization. And this data normalization, it has what they call different forms. But I don't want to go into, I won't go into so much details in that, but let me see if I have any file to explain it. Let me see if I have any other file to explain. Okay, I don't have anyone here. Okay, let me look for something I can use to explain data normalization for you. Data normalization. If I can see something written ahead. Okay, let me use this one. Okay, I think this is fine. Can you see my screen?
Yes, sir.
Okay. Now this was the table. I think this was the table I was talking about. This is the table I'm talking about. You remember this table now? This, isn't it?
Yes.
This is what I was saying. When you are doing your pivot tables, this is not when you are dragging and dropping, isn't it?
Yeah.
You see, because this one is 10,000, this one Excel can easily handle it. So imagine your transaction is growing to 4 million. You see, Excel cannot deal with this type of transaction when the number of rows get to about 2. Even once it gets to 1,050,000, Excel can never, even 1,049,000, Excel can never handle it anymore, unless you start going to different sheets now. Okay, so this is what we are talking about. So at the end of the day, all the analysis you are doing in your SQL is how do I bring it in this form because of the limitations of Excel. Otherwise, if it's just a small table like this, Excel can handle it. You don't need to bother yourself. Okay, you don't have to bother yourself. So imagine this now. We have different word tables, so we can break a full table. Can you see this table? We can break it into what? Smaller word bits. Can you see that? We can group them into smaller bits. So all these ones are, we can call this ones what? Customer table, isn't it? Country, city, state, postal code, region. We can call this what? Geography or location table, now, isn't it? Product ID, category, subcategory, product name. We can call this one what? We can call this what?
Product table.
Product table. So at the end of the day, this big table, what have I done? I have broken it into how many tables now?
3.
3 tables. I have 1, 2, 3. Then I must now think about how do I link them together. Can you see that? How do I now link these tables together? Then what we are building is what they call what? A relational what? Did you understand that? So this customer database can be one database. Others database can be another database. Do you see that? Sales order is another database. But somehow I will have to link one table. So for example, this is others table. So I have to bring customer ID. I have to bring a city code. I have to bring product ID here. Why did I have to bring them here? Why did I have to bring them here?
Unique identifiers, primary keys.
Yeah, so apart from that, because this is customer table, what uniquely identifies customer table?
Customer ID.
Customer ID. So on this others table, I will have to bring a customer what ID. On your location table, can you see we have country, city, postal code, right? We have state and region. But do you know that naturally you would have said postal code will be a unique identifier, isn't it?
Yes.
Yes. But do you know there are some places that are so large that they may share one postal code, but they are different areas?
Yes.
Is that possible?
Yes.
Is that possible?
Yes.
Yes, like Lagos.
So
Like
large.
Lagos.
They are sharing the same postal code, but they are not the same place.
Yes. Yes. That the city
So
code
because
for
of
each
that,
them.
you now notice that postal code in itself may not be a good word, unique identifier. So rather, what you do, I will now combine two columns, the city and the postal code, to now give me what? A new one. What is this one called?
Composite code.
Composite what? You see, this is what composite key that I now use as my primary word. Do you understand that now?
Yes.
Yes.
Yes, sir.
So at the end of the day, what I'm simply doing, I'm trying to break them into what? Smaller bits. Into what? Smaller what? Bits. Okay? But what I want is that I want a situation where I will have to understand how they are related. Isn't it? I have to understand how they are related. And remember, we say we have one-to-one relationship, isn't it? We have what? One-to-many relationship, and we have what? Many-to-many relationship. Which one do we want to see? Which of them is ideal?
One to many and many to
One
one.
to many and
One
many
to
to one.
many, exactly. So imagine I have these two tables.
That side too is good.
Hello?
Before you reach, you thought.
Sorry. Who is
Sorry,
host?
sir. Sorry, sir. Sorry.
Okay, all right. So imagine you have these tables, right? So table one, table two. Can you see that this product name and this product, you see they match? They just match exactly. You see that? So which means I can just bring these two together and merge all of them together. This is what? A one-to-one. This is a one-to-one relationship. One-to-one relationship. Okay? One-to-many means that these are the unique categories I have here. But here it can appear many times. But here it only appears once. So at the end of the day, I will pick from here. I will pick furniture. You have two. I will pick furniture. You have three, isn't it? If I add that up, it will give me how many? Five. If I add another one, it will give me what?
Same.
It will give me what? 15.
Same.
If I add another one, how many will it give me now? Another furniture, it will give me what? So we have 2 plus 3, 5 plus 5. That is what?
10.
10 plus what?
19.
19. So here will be what? 19.
19.
Office supply, what do you have? 2.
2.
You have 2.
4.
4. You have what?
8.
8. You have what?
11.
Plus what?
16.
16.
So you have what? 16.
16.
Is this not what you do in your pivot table? Then you have technology. What do you have in technology now?
6.
6. Do you have any other one?
No.
No. So what have you done? This is what they call a one-to-many relationship. But think about it this way. There are different databases. This one database, this another database, but they are linked. So this is the ideal relationship you want to see. A one-to-many relationship. But imagine you have a situation like this. You have bookcase, you have chairs, you have labels. You have phones, you have binders, you have what? Appliances. Do they have any relationship?
No.
So it
No.
can be appear many times here. It can appear what many times here. At the end of the day, there's no like a one-to-one. There's also it's a what a many-to-many word relationship. As much as possible, avoid this because you will not, unless you are very careful, you may not always get the right words report because you're going to go and pick different nonsense and put for you. Okay, so you have to be very careful when you use it. Okay, sometimes you may be lucky, it works fine, but most times it will always give you problems. So ideally, what we want to see is a one-to-many word relationship. Do we understand this now? Do you understand this? Okay. So that's your, for example, this is your category table that appears just once. This is also called a dimension table. It's called what? A dimension table. Or sometimes you can call it what? A lookup table. It can be called a lookup table. A lookup what? Table. Why this one that appears many times? It can be called your fact table or your what? Transaction table. Your fact table or your what? Transaction table. Please take note of this. Your fact table, your transaction table. Okay. All right. Because it's your understanding of this that will determine how you build your data models in Power BI. Because if you don't understand how your tables are linked, then if you just drag it, it just repeat the same data all through. You're wondering, how come it's repeated? I'm seeing I should have different word values just like this. But meanwhile, to just repeat everything, maybe to just give maybe the total, maybe 100. You just see 100, 100, 100. Have you noticed that in Power BI?
Yes, sir.
You will drag it and just give you the same thing exactly. So the problem comes from your word modeling. Okay. But you see, for you to break it down this way, so that's exactly what we have done here. We have now broken it down, okay, in this form. So all we will try to build is to ensure that we build the data in such a way that we have a what? One-to-many what? Relationship. But for you to break it into one-to-many relationship, you must be able to identify, okay, what are my dimension tables and what are my what? Transaction tables? So think about it this way. Remember that if you remember our process, you must understand the business problem. From the business problem, you are asking what? The questions, isn't it? So the questions you are trying to answer: who is buying? When do they buy? Where do they buy? Is it not? How do they buy? Which other question which other question again? Who, when, what do they buy?
Where did they buy? Where?
Why did they buy?
You said?
The price of purchase.
Why did they buy?
No, so those ones are now the dimension. So that's now the fact. So that's like your sales table. Which means I want to understand my sales. What do they buy? Isn't it? What do they buy? Which table will answer this question for you? What do they buy? Which question will answer it for you?
Category.
Your category, is it not? Your category table. Isn't it? Who is buying? Which table will answer this question for you?
Customer name.
Customer
Is
table.
it not? When do they buy? Which table will answer this for you?
Other date.
Your date, is it not good? Your date. Where do they buy? Which table will answer this one for you?
Region.
Region.
Region, exactly. Your region. Exactly. How do they buy?
It's to be mode.
Yeah, mode, exactly. The mode in which they buy it. Can you see that? Now, all these are your various what? Dimensions. Isn't it? Or rather, they are describing. They are what? Describing. They are trying to describe your sales. So if you say sales is going down, so this is your fact table or what? Your transaction table. This your transaction table is your menu because you can have many transactions, and this one is one. So that is why under this one, it must be what? Unique. No two person can be repeated. So if I have 10,000 customers, that means it means 10,000 different customers. But sometimes if you look at it in terms of transaction, if I have 10,000 transactions, it can be only 5 customers, but 10,000 transactions. So in my transaction table, it may not be unique. But in my dimension table, it must be unique. Just like we are showing your what category, isn't it? It must be what? Unique. So what we are trying to build here, ask yourself, is this a dimension or is it a lookup, isn't it? Or is it a fact table? So all these ones, for example, your sales, your quantity, your discount, your profits, all these are what? Your transaction or fact table, or what you call your data table. All those questions we are asking, when do they buy? Is it not? What do they buy? Where do they buy? You see, those are your questions. All these are your what questions. Why these ones, the sales, how many are they buying? I can look at in terms of quantity. So it can be in terms of quantity, in terms of discount, in terms of profit, in terms of volume. You see that? All these are what? The transactions table. Why all these other ones are asking the question, who is buying, what are they buying, when are they buying, how are they buying? Okay, so that's how you think about it. The moment you see your table, group them into two. One is what? Your what? Date table, or your what you call your transaction table, or your what? Dimension table or description table. Or what you call your lookup table and your what? Data. They are all used interchangeably. Can you see that? Or another way I can, these ones are your text, your qualitative data, and your what? Quantitative. So if you remember, qualitative by quantitative. Okay, so it is based on this. When we want to now break it down, we now know that, okay, if I bring them together in my customer table, customer ID is my primary key, isn't it? In my geography table, can you see that? In my geography table, what is the primary key there? What is the primary key in my geography table?
The postal code.
Postal code
and
and
Postal code. But remember,
region.
that postal code can be merged with what? The city. So I can call that one
city code. Yeah.
You see that city code is now my primary key. In my product table, what's the primary key?
The product ID.
Product ID. But sometimes product ID may not be very unique. And that is why your experience, your knowledge about that business will help you determine whether that item is unique or not. So sometimes for products, you also even need to what? Merge them together to become what? Product key. That means I can merge the product ID with the product name. Okay, then it now becomes what? Product what? Key. So that product key now becomes what? A primary key. Now it is this primary key, this primary key, this primary key. I will now take to my what? Fact table. Can you see that? Then in this table, they now become what? They now become what?
Foreign key.
A foreign key. So that means I can analyze my customers by the sales. I can analyze my customer by quantity. I can analyze my customer by what? Profits. So there's a way I can link them together. So what I've done here is what they call what? I've broken it down into different parts known as what? Data what? Normalization. But for you to normalize your data, it has certain forms it must follow. It has what? Certain forms it must follow. For now, we take it as three. There are three normal forms. So you have what they call the first normal form, second normal form, and what? Third normal form. Now look at this. Look at this table. Look at this table. Can you tell me what's wrong with this table? Is there anything wrong with this table?
Merged.
What was merged? What was merged? What was merged?
5, 6, 7.
What was merged?
The full names.
The full
physical
names.
address. Movies rented. The phone. No, the movies rented is merged.
Okay, movies rented is merged. Is it not?
Yes.
So first normal form says that every record must be unique. When you say every record, what does that mean?
Every entry.
Every
Every
what?
entry of movies rated.
When you say every record, what does that mean?
The information in each row.
In each row, exactly. In each row must be. So it means I have 2 movies here. In Excel, you would have merged it, is it not? But rather, what are you to do? Separate it now. So I will have Janet Jones, is the same person, so same address. So I will take Pirates of the Caribbean, put it here. The salutation miss, isn't it? I put it there. Then in case for the category, either I go and create another table now for the categories and put it separately. Okay. Or then for the second case now, I'll the same name, the same person, I'll break it another column, another row again, and put it here. So that means you now have different records. So first normal form is saying that every cell must contain a single value. That is why in Excel we say do not merge any cell. Okay. Every record, instead of you merging, what do? Repeat them. So that rule follows what they call first normal form. Do you understand that? It's called what? The first normal form. That every table must be what? Unique. It must have its own unique what? Record. Do not merge anything there. It's as a result of this rule. So it's not because I said it. It's the rule. Okay? Database rule. Now, second normal form is saying that, first of all, there must be something to uniquely identify these people. Because can you see Robert Phil? Are they the same? Is it the same person? Is it the same person?
No, sir.
No,
Robert Phil,
sir.
Robert Phil.
Different address.
No.
They are 2 different people, isn't it?
There's
So which
different
means
addresses.
second normal form is now saying that, first of all, it must follow first normal form. And what is first normal form saying?
Unique self.
Each must be unique.
Beautiful. So second normal form is now saying that in addition to your first normal form, each column must have what? A primary what? Key, a unique what? Identifier. Do you get that?
Yeah.
Good. So for me to have a unique identifier means I must have a way of uniquely identifying what is. So how do I have a unique identifier now?
You introduce, like, if it's their customers, customer ID.
Beautiful. So in this case, it's a video club now. So I'll say membership ID, isn't it? So I'll have a membership ID for this guy. I have a membership ID for this guy. I have a membership ID for this guy. Do you understand it like that?
Yes.
So that's exactly what we have here now. So that's why we have membership ID, membership ID. Can you see that? Have you seen that now? Now, is it unique? Is it unique now?
No, not yet, because the full names are still the same, I think.
Which full names are still the same?
Robert Phil.
Now, Robert Phil, right? Which one will I rely more on to identify the person? Is it the person's name on membership ID?
Membership ID.
Membership
Membership ID.
Okay.
So do they have the same membership ID?
No.
No.
So anytime Robert Phil comes and I ask you, what is your membership ID? I will not ask you what's your name. I will ask you what's your membership ID. Because if I go and ask you your name, I can go and record this guy's own in this person's own. So rather, what do I ask you? I will ask you for your ID. Clear?
Yes, sir.
Yes, sir.
So what you have done, you have broken that bigger table now to a smaller table. Is this clear now? So that is second normal form. Now, third normal form is saying that it must be in second normal form. And what is that second normal form saying? That it must have what? Every table must have what? A unique identifier. Now it has a unique identifier. Is there anything that is also relating these 2 tables together? For example, do you know that I can merge Miss Janet Jones together, and it can be one name. Mr. Robert Phil, one name. Mr. Robert Phil, another name. Can you see that? Or Dr. whatever, another name.
Yes.
So when two columns can also have a relationship in that sense, it's called what? Transitive. It's called what? Transitive functional dependency. It's called transitive functional what? Dependency. So rather, what do you do again? You have to now break it further again. So what have you done? You have broken the tables in the smallest word possible word form. But somehow, do you see they are all related? From this big table, do you see we are broken into 3 tables now? Do you see from this big table, do you see we have broken them into 3 tables now?
Yes.
Yes. And what we have done, that whole process is known as what? Data what? Normalization. Why do we need data normalization? We need data normalization in order to build our data what? Model. It's our data model that enables us to link the database together, and that is why it deals with what? The relational what? Data what? This. So that's your Power BI that you drag and drop. It is your understanding of how your what? Data is going to be built that will determine whether the analysis you are going to do will make sense or not. Once you have done that, so if I want to do any correction for anybody's name, do I have to go here and start searching? Because imagine here, I want to correct somebody's name, Robert Phil, and I say Robert Fields. So which of them? If I go
in their membership ID.
I'm talking about this original date, talking of that original first, that original one. If I go and find and replace Robert, it will change the same people now. But with the way we have broken it down, I will just go to which table now? Membership table, isn't it? I'll just come here. Replace what? Robert Field, where membership ID is what? 2. That's what you change only that person. It's not touching another person. So this whole process is what they call what? Data what? Normalization. I know this is the theory. Yes.
It reminds one of those days where we rent movies, because they don't collect names, they stop collecting names at the point. So they give each person a unique ID.
Exactly.
But when you come, that's what you give to return your movie rented and to take another one.
Exactly. Okay, at least we have an idea of what, when we hear data normalization, data modeling, at least you have an idea now.
Sorry, Dr. Francis, I just want to be clear about something. So what you're saying is that instead of having this big table, that we should have like smaller tables. We should break the tables
into smaller tables
to have different feeds and records.
Yes.
Okay.
So what you are doing is called what? A data model. It's called what?
A data model.
That's why in Power BI, that's why you have something. So let's go back to that our slide now. Here's our slides. Can we see these slides now?
Yes, sir.
Yes.
So can you see this now? This one now makes sense.
Yes.
Now. So this is exactly what you do in Power BI. This is what you do in Power BI. But doing this modeling depends on how well you understand data normalization. Those rules. Okay. So you don't have a situation where you pick one value, you just repeat the total all true for you, or giving you wrong values. Okay. So it's how well you understand how the table relates that will now do that. Okay. All right, that's fine. So basically, your SQL in itself. So let's go to the SQL. So all we have been talking about is understanding the concept of database management. Okay. But you see, MySQL and SQL, are they the same thing?
No.
MySQL and SQL, are they the same thing?
No.
What's the difference?
I think MySQL is the language, the structured query language, while MySQL is the open source software of Oracle.
Yes, MySQL is the software. Why SQL is the programming language? Do you see that? SQL is the language, it's not a software. MySQL is the software that keeps your database. To communicate with that database, I need a language to be speaking with that database. Okay, so that language is called what? SQL, Structural Query Language. So can we differentiate now when you hear MySQL and SQL now? Can we differentiate them now?
Yes, sir.
All right. Now, because we have different flavors of SQL, of DBMS. What is DBMS?
Database management system.
Database management system.
That's the software, is it not? Because we have different softwares. Then when we talk about the SQL, which is the language, then we have what they call the flavor. It's just like saying South. Let me use South. Okay, let's say you have Igbos, maybe those ones from Anambra, Imo, isn't it Enugu? What language do they speak?
Igbo.
Igbo, okay. Now you also have people from Asaba. What language do they speak?
Anioma.
Igbo as well. They speak Delta Igbo.
They are not exactly the same thing, but can they understand each other to some extent?
Yes, they can.
So that is called the flavor of the language. That's called the flavor of the language. Okay. So maybe Igbo will say Ndo. Delta Igbo will say Ndo, isn't it? But at least you understand what they are saying. That is the same way SQL also operates. Generally, there are some things that are the same. But you now see some minor differences. Just minor difference. But as long as you understand what you want to do, you will just look for how it works in that particular DBMS or that particular flavor. That's all. Okay. So the SQL is the programming language that you use to communicate with the database. But what we are saying that the SQL is the foundation. But because you may have different other types of DBMS, MySQL, Microsoft SQL Server, Oracle database, so they may have minor differences, but they at least you already understand. Okay, so when we are going into SQL, remember we are not learning SQL as database administrators. We are learning SQL as what? Data analysts. Okay, now if you look at the syntax of SQL, you have a whole lot. But basically, we can classify them into 5. You have what they call DQL, Data Query Language. Under Data Query Language, the syntax you have under there is select. Then you have DML, Data Manipulation Language. DML is Data Manipulation Language. Under data manipulation language, you talk about what? Insert, update, delete. So when you hear in the politics, they are manipulating results, what are they doing?
They are inserting, they are updating,
they are inserting, updating, or what? Delete. So data manipulation does not mean fraud. But only that is how we have learned it. So it's a database technology. So mean either you are inserting, updating, or deleting. Okay, it is when you do it illegally. But most time we take data manipulation as illegal. So we have DML, data manipulation language. So under that we have insert, update, delete. Then we have data definition language, DDL. There we can create, alter, or drop. Then we have DCL, data control language, grant or revoke. Then we have DTL, data transaction language. Either you begin, commit, or roll back. You know how you save? You know in Excel, how you save Control S. Here you commit or you roll back, undo Control Z, roll back. That's what it means, but in database technology. You see, all these things from here to here, this is what database administrators they do. You as a data analyst, the only thing you do is to what? Query. Can you see that? The major thing you need to learn is how to what? Query. But I will expose you to how to manipulate and do your data definition. All this is for what? Database administrators to grant or revoke access in most organizations. If you are not a database administrator, you have no business in this area. No business. Nobody will even allow you to even go near it. Okay? So basically, what you are going to focus as a data analyst is on how to what? Query. How to do what? Queries. Your basic simple queries, sub queries, and just like that. Okay? So that's the focus of what we are going to be doing as data analysts. Okay? And just like you have in Excel, you have data types. What are the Excel data types you have? What are the data types you have in Excel?
Texts, the strings, numbers, booleans, and
all right. Now you see in Excel, in SQL, you have numeric, date and time, and you have what? Character strings or strings. Okay. Now these are the different types. If you use MySQL, it's not all of them you see here. You may see some. If you use Oracle, you may see some. If you use Microsoft SQL, it's not all of them you see. Okay? So that is how they vary. So some may have text, some may have character. So most will have varchar. Most of them will have variable character. Most of them will have date time. Most of them will have integer. Most of them may have, yes, they may all have integer, but not all may have big money or small money. Okay, so they vary. So these are now the data types, and this is what differentiates them. So when we start it, we'll see how they work. Okay, so basically, what you can do with your SQL syntax, you can create a database, drop database, create tables, alter tables, modify columns, rename columns. So these are the things we are going to be looking at. But this is what you actually need: how to what? Query. Select tables, select all tables, select specific table columns, select data from another database. Okay, so these are the basic things you need as what? Data analyst. Okay, but there are guides that we are going to use. So basically, when you are going into database, right, the major problem you have, some people will say, oh, we are going into programming. I don't know how to program. Please, the process of what you are, why you are doing it is more important of how you are doing it. Okay, focus on your objective. Because if we focus on the mechanical part, you will miss where you are going to. Because you end up focusing on how to do the coding. The coding is not the important thing. The most important thing is understanding what am I trying to achieve. And that's why we say you start with asking the right questions. How much in percentage, or whatever questions you are asking, which is the most expensive product, which regions have the highest sales, all those questions you are asking, put them there. Then the next thing is that once I know the question, the next thing, I already know what I want to achieve. The next is that where will I get this from? Then you now be able to identify the database, where that particular data is stored. Once you know where the data is stored, the next thing you have to ask yourself, okay, now I know the database, okay, I will now need to understand what syntax do I need to connect to that database. Once I have gotten the result, is it in line with what I want? Because how will you know? Because if you have asked which region gives the highest profits, what your result is showing you is which category has the highest sales. Are they the same thing?
No.
Are they the same thing? So it is from the question you want to answer that you now be able to validate whether this thing makes sense or not. So the querying is not the problem, because you don't have to cram all the codes. Just understand how they work, because you may never understand all the codes. But what's more important is that whenever you want the codes, and you see it, do you understand how it works? That's the most important thing. Not about cramming the syntax. Okay, I will never remember all the syntax, but the moment I see the syntax, I should be able to know what it's doing. Okay, and why we are lucky in this era of learning data science, why it's even easy, because you have a lot of resources online. So the moment you know what you want to do, what's next? You just go to Google and say what, how to extract data in SQL. That's all. You see, the how to now becomes easy. But what do you want to do is more important. Okay. Having said that, now little things we must now start taking into consideration. Okay, before you start writing code, any of the syntax in SQL. So the first thing is that the moment you enter a code, a syntax in SQL, you must always end with what? A semi-word colon. Always end with what? A semi-word colon. Okay. Then the SQL commands can be in capital letter. That's those specific SQL commands. They can be in capital letter, but every other one can be in smaller case. Now, these are just best practice. If I write everything in smaller case, it will still work. Okay, but just best practice. Then another thing again, every command should be on a separate line. The moment I finish one, go to the next line, so you can easily read your lines. So if there's any problem, you know where that line is. Now, another thing you must take note of. When you are creating a database, SQL does not understand spaces. SQL does not understand space. I think I showed you when you were doing your in VLOOKUP, when you have a space, you saw the implication of it. Do you remember? In VLOOKUP, when we had spaces, the implication of when you have space in a particular name, you are seeing the name, but Excel was not seeing that name. SQL does not allow you to create any space. So rather, if you want to create any space, use underscore. So that is why you see sometimes when they are creating space, they use underscore. So employee table, not employee table. If you don't understand this one, so rather you create it this way: employee table and not this. So when you are selecting your columns, after every column you put a comma, except the last column. Okay, if by chance. Now, all these things, they are all like grammar, because it will not make sense now to do hands-on. Okay, so let me just quickly open my this thing. Then last thing, we click run. Okay, let me just open my SQL so that we can quickly do something before we go. Okay, yes. So let me share my screen. So do we have it like, so do we have something like this? My SQL workbench.
Yes, sir.
All right. So normally once you set it to connect, you see, you notice that you have a name, they're called root. Can you see root? Can you see this root?
Yes.
Yes, sir. Yes, we can.
Root is your username. Your default username is called root. Can you see localhost? Localhost means that it is on this your laptop, that on this your system. That's why it's called localhost. So that means this localhost is like your server. Okay, and that is why this is like your IP when you want to connect. Okay, they will give you like an IP that you connect with. So you just connect here, just double click here, and it will go straight. Maybe because, sorry, can you mute your mic, please? All right. All right. So in this case, because it still looks, because I have a lot open. So if I have something like this, opened, right? there's nowhere you even see that you have, so this is how you would normally see it. Okay, you have something like this. So this is how it looks like. I'm sure most of you have something open like this.
Yes, sir.
Can you see anywhere you have data? Do you see any data anywhere? Do you see
Just
data?
this way you're showing us.
But do you see any data anywhere?
No.
But if I had opened an Excel file, will Excel not show me the data straight?
Yes, it will.
Yes.
So even if I give you access to this, if you don't even understand database, you don't even know where database is, you are wasting your time. So you see, from a security point, with this one, once your data is here, you can even go and sleep. Because before you even break the code, it's even harder. But for Excel file, the moment I know where your Excel file and I copy that Excel file, I can take that file away now. I go and look for how to crack it. But this one, how will you know where the database is? Okay, so from a security point, so it looks as if there's nothing happening there now, isn't it? Good. Now you see, whenever you want to access a database, you don't know what database you are looking for, isn't it? You don't know what database you are looking for. It's like English language. Likely English language. So I want to find the database, is it not? So I want to tell my SQL, please, I'm looking for database, but I don't know the name. Please, can you show me the database that you have? You just type show database. That's all. Show database. Run. Can you see that? Have you seen it? It has shown all the database. Now I'm looking for a particular database. Okay, I've seen that I'm looking for customer database, isn't it? I've seen a particular customer base. So what do? I'll now tell it, okay, I want to use this customer. So I'll say use customers. Use what? Customer. What am I doing? In the memory, I'm committing what? This customer's memory means that is the what? Database I want to use. Okay, and remember, embedded in your customers, let me see, I'm not, okay, there are no tables here. Okay, let me use another one. Let me use customer. Let me see customer. Okay, let me use customer and check. Okay, so I've committed customer to memory. So now what I want to do, I want to check the tables in customer. So what do I say? I'll say what? Show what? Tables. Show what? Tables. Do we have tables here? Do we have tables here?
Yes.
Yes, sir.
Then the next thing I want to do, I want to see what is inside Superstore table. I want to see what's inside Superstore. So what do? I'll say select. That means select every table. Select star. Star means all. Select all tables from where? From where? From Superstore. Have you seen your table now? Have you seen your tables now?
Yes.
Sir.
So you have seen your table now, isn't it? It's not what you have in your Excel.
Yes. So is it compulsory you highlight before you run it?
Not necessarily. So most times, so let me do another one. So if I want to select, so let me say show. So if I write everything in lowercase, show databases, right? Even if I don't put a comma and I run it, it will still work. But sometimes what I just prefer doing, sometimes when your syntax are quite long, I like highlighting so that I will know it will not go and take something else for me. The reason why you also have to end this is to say this is where this syntax ends, this command I'm giving, this is where it ends. Because if I go and put two together, and run it. Do you see that? Do you know what it's doing? It will run one, pick, run another one, pick. Do you see that? So what I want to do, I want to highlight and say, no, please, not everything. It's just this guy I want to run. Do we understand this?
Thank you, sir.
The moment you understand, show database, use the particular database I want. Show me the tables there. Select all tables from there. If this is all you have learned as data analyst, you are okay. You see, this is coding now. But this is the foundation of all you. If this is all you have learned, some people never go more than this. This is all you just need. Okay, this is database. Then you know what they do? When you tell IT, oh, please, oh, I need the sales report for beginning of the year to this year. They'll go and query it and now say export. Then I'll now tell you sales table. Then to now come as a CSV file. And they will not send to you in your email. This is exactly what they do. So rather than you waiting for them to give you data, you can now connect to them directly.
Sir.
Okay?
Hello,
Yes.
doctor.
Sir, is there a reason why we are leaving one or two spaces in the middle? Like I noticed after the
Okay,
number
no,
one is skipped.
so the reason why is that just to make sure. So if I put them together, it doesn't understand what you're saying. Do you see that? So just to make sure there's no problem. So if I leave this one this way, it should still work. Do you see that? But the moment I bring them like this, it's something else. So it's just to be able to read for me to read my syntax. Okay.
No,
if I even want to
sir,
write it in the proper way, what I would, if I highlight it, can you see this brush? Beautify. So this is how it's supposed to look. Select everything from this table. This is how it should look like. All right, guys. I have another session I need to run into now. So
hello, doctor.
Yes.
The query or the data that we're extracting, there's a time you see delimiter. Is it delimiter or I don't know what that means.
Delimiter. So what is separating? What is separating? What are you using to separate? Either it's comma, either it's full stop, whether it's hyphen, whether it's space or tabs.
Okay.
That is a delimiter.
Okay. Thank you, sir.
All right. So next week, let's hope that within this week we'll try and install make sure everybody your MySQL is working or any of these working. Okay. Then after that, we can now go properly. All right, guys. So hopefully,
Dr. Francis, I actually succeeded to install just SQL Lite for my laptop. So, but with mine, I have to import the data. Like they already
sorry, which one is it? SQLite.
Yes.
SQLite is a little bit different. So when we come next week, I'll show you how it works.
Okay, thank you very much, sir.
All right, guys.
Thank you, Dr.
Thank
you. Right.
Thank you, sir.
Doctor, we still need guidance for installation, so I don't know how we'll get you.
That one we can do that.
Thank you, Dr.
Francis.
You are in the class?
No, not during the class now. In the evening.
Okay.
Now. Whoever is having issue, just snap where the problem is.
Okay. Okay, sir. Okay. Thank you, doctor.
Bye-bye.